This is the solution to example 9 from notes 3.1. And this is an example of an application problem of a quadratic function. So we're told that a farmer wants to fence in his dragons in a rectangular pen adjacent to a river. The farmer has 1,000 feet of fencing to use, so that's one constraint. How should he build the pen in order to maximize the area where the dragons can play? And this is going to be a rectangular pen. And then what is the maximum area? First, make a diagram. Okay, so I'm going to make a sketch. I'm going to draw the river. And then I'm going to draw a rectangular pen, because that's what the farmer's going to build. And I'm going to label the sides of my pen. I'm going to use the variables x and y. And for some reason, these dragons won't cross the river, so we don't need to fence in that portion of it. So the constraint that we're given is that he's going to use 1,000 feet of fencing. So I know that 1,000 is going to be equal to the fencing, the length of the fencing that we use. So that is going to be 2x for these two sides plus y. Okay, so 1,000 has to equal 2x plus y. That's the constraint. In this case, it's like almost a perimeter. I'll call it P. And the area of the rectangle, that's what we want to maximize, is going to be x times y. That's the area of the pen. So right now, we have the area as a function of two variables. So we have a equals x times y. This is the area as a function of two variables. And often in these types of problems, it's easy to write the function in terms of two variables, but we really need to write the area as a function of one variable such that we'll be able to find a maximum or minimum. That's what these problems are often about. So how can I write this as a function of just one variable alone? I can use the constraint that we were given, that we only have 1,000 feet of fencing to write one of the variables in terms of the other. And here it's easier to solve for y because then I won't get any fractions. So y is equal to 1,000 minus 2x. And we are going to substitute that in for x in our area function. So we can get a as a function of just x is x times this expression for y, which is 1,000 minus 2x. And now we have what we need. We have the area as a function of one variable, which is just x. There's two different approaches that we can use to solve this. So method one would be to use intercept form. And method two would be to use general form. And you can use whichever method makes more sense to you. So we'll begin with intercept form. This function is already written in intercept form. If we're trying to maximize the area, that means we're trying to find the vertex. So in both cases, our goal here is to find the vertex because that's where the maximum area is going to occur. So if a function is given to us in intercept form, the x value of the vertex is midway between the two x-intercepts. So let's find the x-intercepts. We'd have 0 is equal to, setting the area equal to 0, 0 times 1,000 minus 2x, which means the x values for the x-intercepts are x equals 0, or we can solve 1,000 minus 2x equals 0. So 1,000 equals 2x, dividing both sides of the equation by 2, we get x equals 500. So the x values for the x-intercepts are 0 and 500, and the x value of the vertex is 0 plus 500 over 2, which is 250. Okay, that's the x value of the vertex. Let's find the x value of the vertex using general form. So if I want to use general form, what I could do is a of x is equal to x times 1,000 minus 2x. So I'm going to convert this to general form, and I'll get 1,000x minus 2x squared, distributing the x. I'll rewrite this in standard form with the x squared term first. So descending powers of x, so negative 2x squared plus 1,000x is equal to a of x. And then when it's in general form, we know the x value of the vertex occurs at negative b over 2a. In this case, b is 1,000, so negative 1,000 over 2. A is negative 2, so we'll have 2 times negative 2, which is negative 1,000 over negative 4, which is 250. So in both cases, we found the x value of the vertex at 250. And from this point, we can go ahead and continue to answer the question. So it says, how should he build the pen? So one side, x is going to be 250. That's the dimension here. And the y value is 1,000 minus 2x. So 1,000 minus 2 times 250, which is 1,000 minus 500, which is 500. So the pen should be 250 feet by 500 feet. And the maximum area is either the product of 250 times 500, or we can find the maximum area by substituting 250 into our a of x formula. So a of 250, which will be 250 times 1,000 minus 2 times 250, which is the same thing as we just found for the y value. So it's 250 times 500, which is equal to 125,000 square feet. So the maximum area is 125,000 square feet.